Hello friends, in this video we are going to see about Vedic Maths, history, news and technique. And like Vedic Maths means something which has been mentioned in Vedas or some other old sayings. That's what our perspective will be. So for that illustration, just another analogy, like where the aesthetics, how the aesthetics has been described in ancient times. So Vibhava, Anubhava, Vyabhichari, Samyoga, Rasa Nishpatti. So this is mentioned by Bharata Muni in Natya Shastra, like about Rasa theory, or it is called as Rasa Sutra. This is topic is in aesthetics. So it will be like why this thing has been highlighted is like this is how the concisely they used to write. So from that we have to understand. For that illustration, this saying, this aphorism, this one has been taken as an example, and the meaning of that sutra or that theory is been highlighted below. Next, if you see in Vedic Maths, similarly Nikilam Sutra is there, and there are also other sutras are there which are mentioned, which I've seen in textbooks. So if Nikilam Navata Charamam Dasata means all from 9 and the last from 10. So the meaning of this has been mentioned here. I will not go into the meaning because we are going to see in the examples itself how the technique works. Next, there are some points of contention in news, like some point of time it has been mentioned like everything is Vedic and something is like nothing is Vedic something. So there are points of contention. We will not go into the contention. We will just go into the techniques. The technique 1, technique 2, like that only it will be illustrated. So for conciseness and also for clarity, this approach has been followed. And how do we do about a single and double digit multiplication? Here in this presentation we will only see about single and double digit multiplication, and we will not go into triple and 4 digit multiplications. Those techniques are very similar to the single and double digit multiplication. If you follow this one, we will be able to find out how to do the multiplication in the other cases as well. So how does the multiplication method work? So there are two multiplicants. There are two numbers, and the two numbers are called as multiplicants. And let us consider the numbers as ax plus b into cx plus d. They are in that format for a double digit number. So for example, when we want to multiply 13 into 12, 13 is going to be 10 into 1 plus 3. 12 is going to be 10 into 1 plus 2. So 10 x is equal to 10. That is the same base. So if we see in equation 1, the coefficient of x square is AC. The coefficient of x is AD plus BC, and the constant term is BD. So if we write ax plus p on top and multiplied by cx plus d on below, we will be able to see that the coefficients are going to be very easy. The straight coefficients like a coefficient of x and x in both terms has to be multiplied for x square, and cross multiplication will also come for the x term, and it has to be added, and the last term will be the last two terms, the plus b, the plus d terms has to be multiplied. So if we write one below the another, and if we write this formula, we will be able to see how the thing works. In the next slide I will show that example. So in equation 1 there are three parts of the coefficient, x square, x and a constant. As I mentioned, the 3 has to be in 13 and 12. In case of 13 and 12, so x is equal to 10. So first we will see about a is going to be 1. For 13 and 12, a is going to be 1, c is going to be 1, b is going to be 3, and d is going to be 2. So when we do this value, we see that 100 into 1 plus 3 plus 2 into 10 plus 3 into 2, that is equal to 100 plus 50 plus 6, that is equal to 156. This is the value of the multiplication. Next, if you see, there are few more examples using this technique. I just noted down the technique name which is mentioned in the book, and also the book reference I have mentioned there. So 13 into 12, we are splitting into 3 parts. So 1, and the 1 into 2 plus 1 into 3, that first one comes from 1 in 10th digit in 13 and 12. And the last part 3 into 2 comes from the last term, unit place. So when we put together all these terms, we get that value. Similarly for 27 into 32. In case of 27 and 32, if we see 7 into 2 is going to be the last term, we are getting 14. We should not write the 14 as such. We should transfer that 1 to here. It should get carried forward to the left column. So in the left column we have by cross multiplication 2 into 2 plus 7 into 3. So 25 we have. So this 1 gets carried forward there and it becomes 26. And 26, similarly the 2 from here should get carried forward to 6. So now if we see 5 has become 6 and 6 has become 8. So the value is 864. Similarly for 76 into 52 and 87 into 68, everywhere this technique in 87 into 68, if we see 11 is getting carried forward there. Not the 1 alone, 11 is getting forward. Only one digit can be there in that place. So the remaining number is getting carried forward to the left side. So this is the technique. Next, technique number 2 is two numbers having nearest base. So nearest base means 7 into 8, for example, for a single digit multiplication. So 7 and 8 both are near 10. So 7 has the remainder after for 10, 7 has the remainder 3 and 8 has the remainder 2. So when the we are going to say like we are splitting it into two parts. The remainder part we are multiplying, 3 into 2 we are multiplying, and the other part 7 plus 8 minus 10, the base we are minusing. So when we do that, we get the value as 5 and then slash 6, that is equal to 56. And for example 93 and 92, 100 is the nearest base in terms of 10 decimal places. In terms of 10 decimal places. So 100 is the nearest base. So there 93 is going to be the value and 7 is the remainder, and 92 is going to be the value and 8 is the remainder. So 93 plus 92 minus 100 slash 56. That 56 has come based on the remainder 7 into 8. So now if we see here 56 is here, the 5 is not getting carried forward in the to the left side. The 85 is there and 56 is there. We are combining both together, get the value 8556. This is one technique. And the 56 into 98 means here the 100 is the base and the remainders are written on the right for each multiplicand. So 56 and for 56 44 and 98 2. So when we add 56 plus 98 we get 154. 154 minus 100, the base is 100, slash 44 into 8 to 88. So 5488 is the value. Next, if we see modified bases, till now we have seen only decimal bases. For decimal bases we have taken 10, 100, so on. What if some numbers are going to have other bases like 50, 60, like that? If these are going to be the case, if this is going to be the case, this is not like history has not seen something like this. We cannot say like that. Previous civilizations have used different bases. Like 60 has been used in Egyptian civilization, Babylonian. So 60 has been used. So in those cases, how the technique works, the same. Like from there we are using here. This is how, when the base is going to differ, we are going to do some calculations according to that base and then convert it back to decimal. So if we take in case of 42, 42 into 42, like 50 is taken as the base. So remainder is 42 from 42 8 and multiplied with 42 8. So 42 plus 42 minus 50 slash 8 into 8. So 42 plus 42 minus 50 is going to be 34. So 84 minus 50 is going to be 34 by 2. Why 2? Because in order to convert this value to the appropriate and the decimal terms, we are dividing by 2. This is one technique. So if we say for 49 multiplied by 49, Here also we are using the same technique by 2, and the remainder we are multiplying. So here in case in this second example 1 into 1 is 1, but we don't write 1, we have to write it as 0 1. So here in the second case we are getting 48, 98 minus 50, that is 48 by 2, so 24/01. So 2401 is the number. If we are uncomfortable with this idea, next is the another modification on the other technique is 49 into 49 is there. So 49 into 49, the remainder 50 is the base, 49/-1 multiplied by 49-1. So again we are doing the same calculation, 49 plus 49 minus 50. Here instead of dividing by 2, we are multiplying by 5, and then we are keeping 1 into 1. Here if you see, after 48 into 5 is going to be 240. 240/1. We need not put 0 1. So here we are going to put only 1. 2401. So if you take 59 into 59 means 60 is the base. So 60 is the base. So 59 plus 59 minus 60. And that has to be, we get the value as 58 into 6/1. So that is going to be 3481. So this is how the technique works. And 3-digit multiplication, 4-digit multiplication techniques are very similar. We can just have a look at from the internet, and then we will be able to understand it. Thanks a lot for watching.